10 minutes long, or 8 minutes long. That's when class ends. And then I'll sit there and I'll tell it, okay, propagate up to YouTube, right? I'm going to put it up on YouTube, but it takes a while, an hour-long video to be uploaded and then processed the way YouTube processes. It takes a while. So I'm going to lunch. So you won't. So, but I've got the morning video up there, but I might not remember to put the afternoon video up there until Monday or something. So, but you all know where it is on YouTube, right? You all know where it is on YouTube if you needed to get to it. And I don't know why you would need to. The only ones that would need to get to it are the ones that are not here. But nothing to talk about to them, right? I can't talk to them. They're not here. So anyway, the first homework I wanted to do, so this is homework 5. I forget what number it is. Let me look. Yeah, this is just question 1. Homework 5, question 1. And I have a function f of x equals 3x squared plus 2x minus 3. And I want to find, this is part H, f of x plus h. Right, and so this is part of my process for the difference quotient. So this one should be pretty easy. But the key here is to find f of x plus h. I write the original function with a placeholder for x using empty parenthesis. And it's just 20-some years of teaching math and seeing the same mistake happen over and over, is that sometimes we get a little impatient and we want to rush. We want to rush through this. But it's really important to take baby steps. Take a real simple step and know you're doing it right. So notice I rewrote the original function with empty parens. Nothing inside the parens. And I'm going to fill it in with this x plus h. Right? And then I want to simplify, right? So the first one I'm going to distribute. Second one I'm going to distribute to 2. And the last one I'm just going to keep my 3. So so I'm trying to switch the colors so I can see what I've done here already and what I haven't done. And so obviously I'm going to be distributing this out. So I get 3 times x squared plus 2hx plus h squared. And I still have the 2x, I still have the 2h, and I still have the minus 3. Right, so I'm taking my time. I'm trying to do a single little step every time I do it. Now I'm going to distribute my 3. I get 3x squared plus 6hx plus 3h squared plus 2x plus 2h minus 3. And so this is part of the process for the difference quotient. So I'm thinking you're okay there, but I just wanted to make sure you see one of the more difficult problems that we had to do there. How is that for everybody? We okay?
Yeah.
Nice. And of course, MathXL wants the right-hand side in there. I guess they'll prompt you for f of x plus h equals, and they're expecting you to put that in. There's nothing I can combine there. There's lots of factoring I can do, but none of it helps me. So, and you'll get used to, should I do more? And this is a big part of Calc 1. Should I do more with the answer? So in Calc 1, you'll get an answer. You'll look at the book answer, and it'll be different. And your first thought should not be, I've done it wrong. It should be, I have to do something else. I have to go further. And it's usually factoring. You have to do some factoring in Calc 1. I always like to say Calc 1 is like the Algebra 3 class. It's like the hardest algebra you've ever done in Calc, right? So just be ready for that. Let me do another problem here in homework 5. They're going to ask you to do a bunch of adding functions together, taking 2 functions, finding their domain, then add the functions together, find the new domain. Take 2 functions, find the domain, multiply the functions, find the new domain. And the subtlety here is I have to make sure I keep the domain of the original functions intact. Okay, I have to make sure I keep the domain of the original functions intact. All right, and it turns out that the theory behind it is, which I didn't share with you, is that if you take the original functions, the domain of the new function will include the intersection of the domains of the original functions. And so that's a complicated thought, but let's see where it comes into play here. So I'm trying not to repeat the problems I did in the morning class in case you wanted to look at another problem, but let me go to my Math Excel and open a question here. Oh my God, things are so slow, I can't stand it. I like going into my version of it, not your version, when I'm doing problems, because it allows me just to jump to the answer here. Function evaluation, that's what I just did. I plugged something into a function, and function arithmetic, adding and subtracting and multiplying and dividing, etc. So I think I did, in the other video, I just did, right? So you can see that every time I open the homework, it's a different question. So just know that's what happens. In the other class, I think I did this one. I did question 3. So that's there. I'm also, well, it's different, a little different. So I'll do this one. It says I have 2 original functions, one linear and one quadratic, right? And what do I want to do with the functions? I want to add them. So let me do this one. This is number 3. And instead of me writing it and then going to my other screen, I just take a quick photo of it. It's just the way I always want you to send me photos. So this is homework 5, number 3. And it gives me 2 functions. It gives me a linear. F of x is x minus 2. And g of x is 7x squared. What's the domain of the first function? What's the domain of f? Can you think of a number that I'm not allowed to subtract 2 from? Does such number exist? So it's all reals. Thank you for participating. What's the domain of g? What's the domain of my second function? It's a quadratic. Can you think of a number that I'm not allowed to square?
It's all real.
All reals. So when I put these together with a sum, and the notation is a little bit strange, the mistake I usually get is I'll have my students add these functions and then multiply by x. But if you look at the notation that I prefer, which is f of x plus g of x, it's pretty clear that I'm just adding the 2 functions, right? So I'm adding x minus 2 plus 7x squared. And what I get, and usually we'll try and write it right in descending powers, I obviously get a quadratic. And what's the domain of this function?
All real.
Yep. So my domain here, the domain of h, it turns out to be the domain of f intersection domain of g. It's what I had in the 2 pieces of the domain before, right? So in this particular case, when I'm adding functions or subtracting functions or multiplying functions, I get these intersections of domains. When I'm dividing, I also have to then include, make sure you don't divide by 0. Okay? So there's one little subtlety there. And what I had said to you is when you do these problems, just figure out the new function and figure out the new domain, but then make sure you adopt the domains of the originals, right? But it's easier, it's much shorter to say it's the intersection of the old domains. Let's do another one. So this is this is okay, right? This is easy, I'm assuming. This one I did on the other video. If you want to take a look at that, that's a good one to look at. Let's do this one. I'm going to take the function rad x plus 5 and the function rad of the square root of the quantity 5 minus x, and I'm going to multiply them together, right? You can see that f times g there. F times g, I'm going to multiply these functions together and then figure out my new domain, right? So this is question 5. Homework 5, question 5. I've got a function, square root of, I think it was x plus 5. I can't remember now, but it doesn't matter. It doesn't matter. Yes, x plus 5 and 5 minus x. And I've got another function, g of x, square root of 5 minus x, right? And I want to talk about those two domains first and see what happens when I put my new function together by multiplying. So what's the domain of this first function? The domain of f. I have to make sure that x plus 5 is not negative. So my domain of f is x is greater than or equal to negative 5. And of course, I could write that as negative 5 all the way to infinity. And remember, I can get to the negative 5, so I use the square bracket. But I can't get to infinity, so I use the open paren. How is that for everybody? Thank you. Thank you, Abraham, Ryan. Thank you, Elmer. Yes. The rest of you, are you asleep? Damn it! It's Friday. It's Friday after 12. Come on, Victoria. Thank you. Thank you, Aiden. Thank you. A little less conversation, a little more action, please. To quote Elvis. Okay. What about G? What's my domain of G? Well, again, I need that interior to be positive, non-negative. I can't put a negative of a square root. Well, I can, but not in our world. So I want 5 minus x to be greater than or equal to 0. So I want 5 to be greater than or equal to x. And I, of course, like my x on the left. So I want x to be less than or equal to positive 5, right? And of course, I could write that domain as an interval from minus infinity up to 5. When my x is on the left, it's easier for me to write intervals. I don't know if you understand the subtlety of that yet, but you will. So now look at the intersection of this. Look at the intersection of these domains, right? The intersection of these domains say the domain of f intersect with the domain of G, right? I'm trying to get the pieces of each that match up. And where am I going to go from minus 5 to 5, right? Do you see that? Yes, you with me there? Anyone? Bueller?
Yeah.
Nice. So, but let's see what happens when we take our original functions. Thank you, Oscar, Sarah, Jarrett. Thank you. Let's see what happens if I take these functions, turn it into my new function, right? And the new function they're asking for is f times g of x. I don't like that notation as much as I like this one. F of x times g of x. That one looks a lot easier to understand. And I'm taking my two functions, the square root of x plus 5 times the square root of 5 minus x. And of course, I could take when I'm multiplying two radicals, I can combine to one radical. So I get this function square root of, what is it, x plus 5 times 5 minus x. And of course, I could distribute this, right? I could simplify this. Usually you want to. I get, what do I get? I get minus x squared. I get, my middle terms drop out. Is that right? Yes, my middle terms drop out, and then plus 25. So I get square root of 25 minus x squared. And this function I'm calling h of x. I like to simplify things if I can. I don't want to keep calling this thing f plus g or f times g. I want to name it something else, right? So I'm going to call it the function h. You can use any letter I want. So here's my new function. And remember, what is that? Do you remember what that thing is? It's a quadratic that opens up or down. Man, you're killing me today. You're killing me today. How could the 9 a.m. class have more energy than the 12 o'clock class? Open up or down, quadratic that opens up or down. Smiley face or frowny face, if I want to get official.
Up.
Almost.
Down.
Down. So I'm looking at the x squared term. And if the x squared term is positive, it's a positive smile. If the x squared term is negative coefficient, then I'm a negative people frown. It's a frowny face. This is official language there. So I know it opens down, and it goes through 5 and negative 5. And now remember, it's this particular function here. This is y equals 25 minus x squared. Yes, you with me, Sarah?
Yeah, I have a question.
Sure.
Sorry.
Sure.
So, what was the importance of knowing the domain of the D and F above in order to do this?
I'm trying to show you at a little bit more sophisticated way that the domains of the original functions help me figure out the domain of this new function by getting the intersection of the old domains.
Okay.
Yes, and I'm not quite ready. It's not the big reveal yet. It's coming. Okay. So I'm looking at the graph of this interior function, and I know I'm going to take a square root of it. So if I'm going to take a square root of it, I can only take a square root of the positive pieces. So only the pieces I have highlighted in green. I can also take a square root of a 0, right? So you can see here that the domain of h is going to be from minus 5 to 5. And look, notice that that is already the intersection of the domains that I already got from my original functions. So what I was saying to you Wednesday was I'm saying I'm not going to tell them about the intersection piece. I'm just going to say find the new function, find the domain of the new function. Just be careful not to forget the domains of the original. And you'll see that when I do this next problem, okay? So Sarah, it might be a little clearer now, but it should really be clear after this next problem that I can't forget the domain of the original functions, okay? So one more problem here in this section. And I forget the number, but it's whatever. It's one number after the one I just did, I think. I've got two functions, f of x and g of x. And f of x is 1 over x with a domain of what?
Everything except 0.
Everything except 0. So the reals minus the singleton of 0. Right? And the domain of g is pretty easy. It's all of the reals except for the single x value of 1. Right? And now I have to make sure when I do something with my new function, right? When I'm going to do some arithmetic, I'm going to add the functions, or I'm going to subtract them, or I'm going to multiply them, or I'm going to divide them. I have to keep in mind the domain of the original functions plus the domain of the new function I create. Okay? So let's look at this function. I'll call it h of x. And that will be f divided by g of x. I don't like that notation as much as I like taking the function f of x and dividing by the function g of x. Right? It's that simple. And what do I get here? I get 1 over x divided by 1 over x minus 1. And we'd like to make this thing look nice. Okay? So when we have things called complex fractions, fractions within fractions, we're gonna clear them. Right? We would like our final function to be written as a nice factored numerator over a nicely factored denominator. Okay, now this one is real simple. This is just a keep, change, flip, right? Keep the top function, change to multiply, right? And divide, and then flip the downstairs function. So this is just a simple fraction divided by fraction problem. So here's my function h of x. And I get a nice factored numerator of x minus 1 over x. And look at this function. Look at this function. What is the domain of this function? It looks like only 0 is a problem, right? You see what I'm saying? It looks like only 0 is a problem, but I'm forgetting to think about what was a problem in the original functions. Not only was 0 a problem in the original functions, but also 1 was a problem. And so that's the subtlety here. So I need to be thinking about the intersection of the old domains and the new domain. So I have the intersection is all of the reals minus a set of two x's, 0 and 1. And of course I could put that in into interval notation of minus infinity to 0, union 0 to 1, union 1 to infinity. Right, so that's what we're looking for on this one. Here's my domain. Now I want to look at those on Desmos, okay?
Professor, I have a question.
Sure, Ryan.
If when you write the interval notation and you don't put like the middle part 0, 1, is that still correct?
So if I leave out all of these numbers, that means I can't put in 1/2. Right? So if I leave that out from the domain, I'm telling the machine, if someone puts a 50-cent piece in, don't accept it. But of course you know you can put a 1/2 into this, right? So h of 1/2, right, is what? 1/2 minus 1 over 1/2. That's minus 1/2 over 1/2. That's a negative 1. So I'd be losing that output. If I don't allow all those inputs, I'm losing a bunch of outputs. And I think the subtlety, what you're missing there, is there's a whole bunch of numbers between, right? It looks like if I just combine these blue pieces, it looks like I get everything, but I'm forgetting there's a whole bunch of numbers between 0 and 1. In fact, uncountable number of numbers, right? So I want to look at those on Desmos. I want to look at these functions on Desmos and make sure I'm driving home this point of I have to consider the domain of the original functions. Okay. So I'm going to Desmos here. Desmos is a lot stronger than our calculators. So, but you want to make sure that you're doing things on your calculator as well, so that when you get to the test, you don't want to have the case that you're practicing things on Desmos, and when you get to the test, you can't use Desmos, right? I'm telling you, you cannot use another computer. When you take your test, you're going to be looking at your computer with Math Excel open, locked, can't go anywhere else on it. And then your phone is going to be off to the side watching you take the test. That's me watching you take the test. It's a horrible time of my life, and then you're going to be writing everything on the paper, right? So, so you want to make sure that if you do anything on Desmos, you also practice it on the calculator, okay? So I'm going to my graphing calculator here on Desmos. And if there's something real weird, yeah, Rachel, 1 second. If there's something real weird that I want you to see on the calculator, I'll make sure I show it on the calculator. Okay? Go ahead, Rachel. What were you going to say?
What if we have trouble with our cameras for Zoom?
So for the test?
Yeah.
I don't know what to say. You need to borrow a phone. So the only camera that's going to be looking at you is the camera on your phone or another computer, and that's going to be watching you while you take the test. And it's weird. It's me watching you take the test, but it'd be the same in the classroom. I'd be walking around. So I've had students have to borrow something. You can borrow a computer from the school that would have a camera on it. I've had students borrow a phone for that 1 hour and 25 minutes from a brother or sister or even a parent. Yeah, so we'll start talking about that horrible process Monday, okay? So I want to graph my original f of x divided by g of x, which was 1 divided by x, highlighting it all, divided by 1 divided by x minus 1. And take a look. Clearly, there's the domain of 0 is out of there. There's no place when x is 0 that the function exists. And there's a unique point when x is 1. And you can see that I'm going to highlight it here. It looks like 1 comma 0. Right? So that particular point doesn't exist on the graph. There's actually like a hole there. Like it was like a break. This was a roller coaster ride. There's a break in the track at 1, 0. Right? And so what am I showing you? Now watch my h of x. What did I get for h of x? I get y equals x minus 1 all divided by x. And look at this. It's the same function. You see that? It's exactly the same function. It just recolored it a different color, right? If I turn off of the function h, you see my original function there without me simplifying it. It's there, but I have to consider the domain of no zeros and no ones, right? And then when I even though I get my brand new function, it still has the same domain, right? No zeros, no ones. What do you think, Sarah? Any of that click a little bit more now?
Yeah, so basically they equal the same thing. It's just showing the domain represents what it would be. Okay. Yeah, that makes more sense.
Yeah, exactly. And so if I look at this graph, does it look like there's a hole at 1, 0? No. But I have to be thinking about the domains. I have to be thinking about what am I allowed to put in, right? What am I allowed to put into the original functions? That's going to still be true when I create my brand new function. All right, we're ready to finish section 2.1, and that is talking about the difference quotient. And we're going to try and look at the subtleties of what the hell are we doing this difference quotient for. And you have to understand we've been torturing you all of your lives just for next semester. We've been torturing you with all of this math year after year after year just so that you could understand calculus. Just so that you could understand why I need a certain density of steel to build a building. Just so that you could understand why, how my code could be faster for doing turbulence, fixing the turbulence on airplane wings. Just so you could understand how we could get a rocket out of the Earth's atmosphere without it bouncing off our protective shield and breaking into pieces and killing everyone on board, right? So, and all of that is calculus. All of what we're talking about is calculus. We can't have the technology we have and the knowledge that we have and the medicine that we have without calculus. So that's why we're torturing you with this stuff. Just so in your fields, if you ever need to consult a mathematician, you're going to be able to communicate with them, right? So that's why we're making you take calculus. So anyway, sorry. Difference quotient. Let's just do one real quick. A nice simple one. So let's say f of x is equal to x squared. And let's show that the difference quotient has a dq of 2x plus h. So I want to show you that I get that answer from my difference quotient here. So how I asked you to start was say, write f of x with empty parens. Write f of x. Whenever it's a polynomial, this is my process. Write f of x with empty parens. Inside, evaluate with x plus h. Simplify. I get x plus h, that quantity times itself. I distribute, I get x squared. I get an hx, I get another hx, I get an h squared. Hopefully that can be memorized soon so that you can go right to this step. X squared plus 2hx plus h squared. Is everybody okay with me here? Anybody need a little time here?
Sorry.
Go ahead.
The box, I thought it said 2x plus h.
Yes, it does. So I'm not there yet. So remember, I kind of had a step by step for us. We're going to find f of x plus h. We're going to find f of x. We're going to subtract them. We're going to divide by h. We're going to simplify. And once I get there, then you're going to see I have the answer that's in the box.
Okay.
Yeah. So what's next is write f of x directly below and do it strategically so that it's lined up with the pieces, right? So I want my x squareds lined up because I'm going to subtract them. I'm going to subtract them and these are going to go away. Notice that the only terms left have a factor of h in them. So I've got my difference piece now. F of x plus h minus f of x is 2hx plus h squared. There's my difference piece. How am I going to get the quotient? I'm going to take that difference and divide by h. Let's take the difference and divide by h. And so what do I have now? I have an h times a 2x plus h, all divided by h. And my h's will now cancel. And there's my final answer. The difference quotient is 2x plus h. So it's easier than the one we did the other day, right? We did a difficult one on Wednesday. And then, but I did that one with the morning class today, and they were like, oh my God, I can't handle it. No, they didn't really say that. But let's look at, so we can do a difference quotient pretty easy if it's a polynomial, and the process is the same every time. So, but let's look at the subtleties of what this difference quotient is actually telling us. Better before that, let's make sure it's correct, right? So I want to look at, every time I do one of these difference quotients, I want to look at the original function, and I'm going to pick 2 points on that function, right? So in my particular case, I'm going to pick 0, 0, and 3, 9. And I'm doing this completely randomly. Well, not really. But I'm allowed to pick anything I want as long as it's in the domain, right? And we know this particular function has the domain of any x. So I want to find the line that cuts through those 2 points. I missed a little bit, but you get the idea, right? Yeah, it's better. Not really. So I want to get the slope of that secant line, right? So the slope is going to be 9 minus 0 over 3 minus 0. which is 9 over 3, which is 3. So it makes sense that I get a positive slope there, right? I can look at that red line and know that it's a positive slope. I want to do the same with the secant line. So this is just the slope using 2 points. And now I want to see if my difference quotient gets me the same thing. So I'm going to decide on one of my x values as being my x, and then I want to figure out my second x value and figure out h. And so you should see that this distance here is h, right? Remember what I'm doing. Remember what I'm doing. I'm doing x, comma, f of x, x plus h, comma, f of x plus h, right? And I'm doing the slope with those 2 points. And that it's clear, it should be clear that the distance between the two x values is my distance h. If my distance h is moving to the right, it's a positive h. If it's moving to the left, it's negative. So I'm going to pick 2 times x plus h. Sorry. I'm going to pick x to be 0. And if x is 0, what's h? If my first point I'm picking is x is 0, my second point I'm picking is x is 3, the distance between them is h. So h is 3, right? And what do I get? When I plug in 2 times x, 2 times 0 plus 3, what do I get for my slope? 3.
3.
Same answer. My difference quotient should give me the same slope of the secant line, whether I do it with 2 points or I calculate it with an x and an h. How are we doing? We okay?
Yeah.
Good, thank you. Elise, Wilder, Aiden, thank you. So I want to take a look at this particular thing with a fixed point, and I'm going to take the fixed point 0, 0. Oops, 0, comma 0. Right, I'm picking points on the curve. And I want to pick the point x plus h, f of x plus h. Right? But x is fixed now. Yes, you with me? So I'm going to pick 0 plus h, f of 0 plus h. Okay. So that is going to be h, comma, h squared. And I'm going to confuse a few of you here, but I'm not too worried about it. Okay. So, and I'm going to add this slider h. So I can see my new point is some h, comma, h squared later. Right? Do you see it? So that second point I'm controlling with this slider. Oops. There we go. So my second point, oops, stop there. I'm controlling with this slider so you can see my second point. And I want to connect those 2 points to the secant line. I'm doing calculus right now, by the way. Okay? So if you start having a little bit of a panic attack, don't worry. This stuff is not expected of you until chapter 3 next semester. Okay? So, but I'm trying to look at the subtleties of what we're doing here and why we're torturing you with this. So I've got some fixed point on my curve, and that's totally up to me. I chose 0, 0. Okay? And I'd like to pick some point later. I don't know what it is. Right? But this is x plus h, comma, f of x plus h. But I know the x value, right? I know the x value I picked because my first point is fixed, and the x value of that first point is 0. So I've really got here 0 plus h, comma, f of 0 plus h. But I know 0 plus h is just h. So I know this is h comma f of h. But I know the function. The function is whatever I have, square it. So I actually get h comma h squared. So that's how I did all of that in my head to put that second point on. And now I want to connect those with a line, right? So with our line, we have our middle school version, y equals mx plus b, or the version we're going to use from now on, y minus y sub 1 equals m times x minus x sub 1, where x1 and y1 are a fixed point, and m is the slope of my secant line. So I have x1 and y1. Those are my fixed points. Those are 0 and 0, right? So y minus 0 equals m times x minus 0. All right, well, that's kind of nice because that just gives me y equals mx. And I know the slope of my secant line. The slope of my secant line, I just figured out, was 2x plus h. So I get y equals 2x plus h times x. But what is my x value? Well, it's x sub 1, right? It's fixed. What's my x sub 1 value? It's 0. And my h value is h. So I'm just going to get y equals hx. So remember what I said. If you're having a little bit of a panic attack here, it's okay. I'm just trying to show you where we're going with this stuff. So I'm going to graph that line, y equals hx. Oops, y equals. There it is. Look at it. It connected my 2 points of my secant line. As I move h, I will change the secant line. As I move h, I change the secant line. When h goes to 0, notice that I have one single line through a single point. Now all of a sudden I have a tangent line. Secant line will go through a curve at 2 points. A tangent line will go through a curve at 1 point. Can I create a line with only 1 point? Your answer used to be no. Your answer after Calc 1 is yes. So now all of a sudden I can create a line using a single point, right? I can create a line using a single point. Anybody freaking out a little bit here? No, at least it's okay.
A little bit.
A little bit. Abraham, is that, yeah, and you can, I have the chat up, so if you can say it to me privately if you want to. I don't have to share your fear with everybody or panic. Watch the other class, the one I did with the other class, and then you'll really have a bit of a panic attack.
Yeah, I just think I need to practice it a little bit more, and I'll get it.
Yeah. So now remember where I stopped with the pre-cal. I found the secant slope. I checked it with 2 points, and I checked it with an x and an h. Done. That's what our level is. The calc level is taking that secant line and turning it into a tangent line. And this is called the derivative. It turns out that the slope of the tangent line is the derivative. All right, but that's going to be, a third of the way through next semester. I am a little worried about our schedule, so we are taking pre-cal now in fall. That means we should be taking Calc 1 in spring, and then that leaves us 2 options: Calc 2 in the summer, which is a very difficult course, or wait to fall again to do Calc 2. So as we're getting close to that, you can feel free to contact me. I'm pretty sure I won't be teaching Calc 1 next semester, so you'll have somebody else. But I'm going to get you ready for Calc 1 with any teacher. Even find the most difficult, most challenging teacher, and you'll still be able to handle it if you can do everything I'm trying to teach you this semester. Okay. So, but Calc 2 in the summer is not for everybody. It's very fast. Usually we do Calc 2 in 15 weeks. You're going to do Calc 2 in 5 weeks if you take it in the summer. Very fast. Let's do another difference quotient. Ready? How much time is left? Only 23 minutes. Yes. Lunch is ready. Okay, let's take a look at a linear function. Okay, so also a polynomial, right? So when we're doing this stuff with polynomials, we want to use the same process. I find it makes it easier. And you're going to see we're going to do difference quotients with 3 types of functions. Polynomials, and when I do it with that, I have a process. Basically, I'm going to end up factoring. I'm going to use radicals, so square root functions. And when I do that process, and I'll do one today, I use conjugates. And then the last one is the rational functions, so fractions. And when I use that, I'm going to use LCDs. I'm going to try and do one of those real quick today too. So let's go with one more polynomial. Let's say f of x is 5 minus 2x. You can already tell me what the slope is here. What is our slope here at any point?
Is it 2?
Negative 2.
Negative.
So guess what? Our difference quotient is negative 2. But let's show it. Okay? So we're saying find the DQ. And I grew up in New Jersey and we had a place called Dairy Queen. I don't even know if it exists anymore, but it was an ice cream place. So whenever I think of this, I'm going, I want some ice cream, even though I'm diabetic. So f of x plus h is 5 minus 2 times empty parens, right? Where I'm putting my empty parens, I'm evaluating with x plus h. Whenever I do a difference quotient with the polynomial, I'm keeping this process. I want to simplify this. So I get 5 minus 2x minus 2h. So evaluate your original function at x plus h. Second step, write your original function f of x and write it down strategically. So f of x is the original 5 minus 2x. Notice the 5's are lined up, the 2x is lined up. Because what am I going to do with these? You okay, Brian? Brian, you okay? Yeah. I just saw your mic go on, so I wanted to make sure you didn't have a question. So I'm going to subtract these, right? So the 5's are going to go away and the 2x's are going to go away. So notice what I have now for my difference. F of x plus h minus f of x is just negative 2h. Remember, I should only have terms with factors of h in them. If I have a single term without a factor of h in it, I made a mistake. I'm going to now turn this into a quotient by dividing by h. And of course, you see my h's will cancel, and I get the difference quotient of negative 2. If you think about it, if you think about the line 1, 2, 3, 4, 5, right? No matter which 2 points I pick on here, the secant line is going to be the line itself, right? So no matter which 2 points I pick, I'm still going to get that same slope from my difference quotient. Same slope as the original line. How are we doing? That one seems too easy, right? The one we did Wednesday, too difficult. The one we did today, right in the middle, right, with x squared. Let's do one with a radical. So we're finding the difference quotient. If f of x equals the square root of x minus 2, find the DQ. So we're finding the difference quotient for a radical function. I'm pretty good at graphing this, but if you're not good at graphing it, right, you should throw it in your calculator, right? So it actually says x minus 2 in there, but I know, and we're going to talk about this later, I know 2 is my new origin. So it looks just like a square root function, but it's shifted over to the right. And of course, I could always go into my TI-83 or into Desmos and graph this and make sure I see it, right? So there's my function. I want to find the difference quotient for this. When I do the difference quotient for rationals, for fractions, or for radicals, square roots, I'm going to go right into I'm going to do, my process is a little different. So I'm going to say that my dq is f of x plus h minus f of x all over h. And so I'm going right in. I'm not doing any other side work. I'm doing square root of x plus h minus 2 minus the square root of x minus 2 all divided by h. So notice I just went right into the whole difference quotient formula. First evaluating at x plus h, then evaluating at x, and then taking that difference and dividing by h, right? If there's parentheses in here, I usually like to get rid of them. So I get the square root of x plus h minus 2 minus the square root of x minus 2 all over h. Is everybody with me?
Yes.
Nice, nice. Nice, thank you, Yvonne. Yvonne, thank you, Sarah, thank you. Ryan, thank you, Jarrett. Thank you, Elise. Thank you, Rachel. So I want to use a conjugate here. And you're going, well, how am I supposed to know that? Because I'm your teacher. I'm telling you what you're supposed to do. So I want to use a conjugate. And I'm looking for the conjugate of the radicals. So I want to use a conjugate here. And the secret to my conjugate is I'm just changing this middle sign and then everything else is staying the same. So I want to use the conjugate over itself. So I'm doing square root of x plus h minus 2 plus square root of x minus 2 all over itself every time. I want to multiply my function by 1. So I have to use something over itself to be my factor, right? And the trick is conjugate over itself. Conjugate over conjugate. Where I'm going to manipulate this is where I see the conjugate's evil brother, the conjugate pair, right? So I'm looking for the conjugate pair. So downstairs, I'm not going to manipulate at all. I'm going to let that one just go for the ride. Okay. So upstairs here, I'm going to distribute. And of course, I know that my middle terms are going to cancel out, right? From like algebra 1, a plus b times a minus b is a squared minus b squared, right? So I know those middle terms are going to drop. I don't have to think about that. So I'm going to get the square root of x plus h minus 2 times itself minus the square root of x minus 2 times itself, all divided by whatever is downstairs. I'm leaving it alone. I'm not going to touch this downstairs piece. And it's about doing problems that you'll learn the subtleties of when should you work on the numerator, when should you work on the denominator. If you do enough problems, you'll start to recognize. So upstairs, I really know what I know. I'm going to get just a squared minus b squared. So my radicals are going to cancel, right? So for my difference quotient here, I have x plus h minus 2 minus an x minus 2 all over that same downstairs. What is supposed to happen upstairs is everything without a factor of h in it should go away. If it doesn't, you made a mistake somewhere. So look at what's going to happen to me upstairs. I'm going to distribute that negative. I get x plus h minus 2 minus x plus 2. Right? I'm distributing that negative. And I'm really taking my time with these problems. I like to say I'm Polish, I'm not Russian. But even if I was Russian, it's still funny to say if I'm Russian, but I'm not Russian, right? So I'm trying to take my time. I'm trying to do baby steps every time so that it's really clear what's happening. And now I can see that my x's will go away. My 2's will go away. And you can see the only term I have left upstairs has a factor of h in it. Don't try and save trees when you're doing math. When you're learning this math, when you're doing Calc 1 and the problem takes 7 pages, let it take 7 pages. When you're doing Calc 2 and the problem takes 13 pages, let it take 13 pages. Don't start writing sideways up the page. Use paper. And then when you get your job and you're making $100,000 a year, go plant a tree. Make up for it. Okay? But don't try and save paper. Don't go too fast. Take your time. Okay? Now I see my h's will cancel. And I finally get my difference quotient. The 1 over the square root of x plus h minus 2 plus the square root of x minus 2. And there is the difference quotient. Let's double check that we got this right by picking 2 points on our curve, calculating the slope, and then see if we get the same result using the x and the h value in the difference quotient. So looking at my curve, I'm going to pick 2, 0, and how about 5, no, I don't want to, 6, 1, 2, 3, sorry, 2, 3, 4, 5, 6, comma, 2. Is that right? Remember, y equals the square root of x minus 2. So when I plug in a 2 to that, I get square root of 0, which is 0. When I plug in a 6 to that, I get 4 minus 2, square root of 4 is 2. Right? We in agreement there? So I want to get the slope of the secant line. So 2 minus 0 over 6 minus 2. That's 2 over 4. I get a slope of 1/2. Everybody agree?
Yes.
Thank you, Manish. I want to check my secant slope as well. So I can pick my x value to be 2, or I can pick my x value to be 6, right? If I pick my x value to be 2, what's my h value? How much further to the right am I going for my next point? H is 4, right? Is that agreeable there? If I pick my x value to be 2, my h must be 4. Is that agreeable? 1, 2, 3, 4. Everyone agree with me there?
Yes.
Yeah.
Good. Let's check the slope of the difference quotient, slope of the secant line. And what did I get? I got 1 over square root of x, which is 2, plus 4 minus 2. Right now I'm using the difference quotient formula, plus the square root of 2 minus 2. So it looks like I get 1 over the square root of 4 plus square root of 0. That's 1/2. I get the same result. Pre-cal is done. With the difference quotient, I am comfortable getting the difference quotient, double checking the difference quotient with arbitrary points on the curve, and making sure I get the same slopes. Let's do one more, and then we're done for today. We're done for the week. Thank God. I hope you all have a great weekend.
Thank you.
Thank you. I'm psyched for this, even though I've got a horrible anniversary tomorrow, an anniversary of my father's death. an anniversary of the loss of some people I know from my hometown. But I'm going out celebrating. I'm going to go celebrate tomorrow. Celebrate 9/11. I want to do one more today. And it's okay if you're a little confused about what's going on. You just got to practice. You got to ask for help, right? So let's do a difference quotient with a rational function. If I have a polynomial, I have a process, and I end up having to factor. If I have a radical, I'm going to use a conjugate. And if I have a rational function, meaning a fraction, I'm going to end up using an LCD. So let's do a nice easy one here. F of x is 1 over x. So I have a rational function. I have a fraction as my function, right? So I want to find my difference quotient as 1 over x plus h minus 1 over x, all divided by h. Make sure it's clear that this first piece I'm putting in green, I'm taking my original function and evaluating it at x plus h, right? Make sure that's clear to everybody. Make sure you can see that I used to have 1 over x, now I have a 1 over x plus h, because I'm replacing the x with some x later, right? Some further to the right value. And then my second piece is the original function. So I'm doing f of x plus h minus f of x. Sometime later on the curve, and the whole curve itself, and then all divided by h, right? So that should be pretty clear. And in this particular case, if I can get rid of parentheses, I will, but then I want to multiply by the LCD, or better yet, a common denominator over itself. So my common denominator here is always take the two denominators and multiply them together. So I'm going to use x times x plus h all over itself. Why? Because if I'm going to keep the function the same, I have to multiply by 1. I can do two things. I can multiply by 1 or I can add 0. And you'll do both of those tricks quite a bit in the next 3 to 4 semesters. So I take my interior denominators, by the way, which are x plus h, x, and 1, and multiply them together. And that's my common denominator. So I take all the interior denominators, right? The denominators inside each term, or that are a part of each part of the fraction. But not the whole denominator, not h, right? Just the interior denominator. Does that make sense? And so I'm going to distribute now. Upstairs I'm going to distribute. Downstairs I'm going to leave it alone. I'm still distributing. So I get an x times x plus h over the x plus h. I get a minus x times x plus h over the x. And I get an hx times x plus h. Let me highlight the original problem in black. In green. Look at my original problem in green. And look at everything else. It's my LCD. It's my common denominator. Everything else that's left in black is the x times x plus h. I'm taking my time when I do this. I'm not trying to save paper, right? I can see that my x plus h's will cancel and my x's will cancel. And I rewrite nice and slow. X minus parenthesis x plus h all over hx times x plus h. I'm not in a rush. I'm Polish. I'm not Russian. My girlfriend's also Polish. And the stereotype of Polish people is we're dumb, right? But my girlfriend said to me, straight face, didn't even realize what she said. She said, I'm so good at putting my contacts in. I can do it blindfolded. That's the essence of the stereotype of the Polish people, is that we're that dumb. But how do you put contacts in if you've got blindfolds on, right? That's the funny part. But she didn't even realize it. She's like, "Why are you laughing?" Okay, so I'm going to distribute my negative here. I get x minus h all over hx times x plus h. And you can see that the x terms are going to go away upstairs. Notice that they don't have factors of h in them. Better than that is noticing what's left has a factor of h in it. So now I have negative h over hx times x plus h. And my h's will cancel. And so I can finally see my difference quotient of negative 1 over x times x plus h. You just got to do a bunch of problems, okay? So homework 6 is there for you. I think there's 2 polynomials, maybe 3. There's at least 1 rational and 1 radical. 1 with a fraction, 1 with a square root, okay? At least. And there might be more, I can't remember. But they take a while, so I try not to give you too many problems. The thing is you could create any function you want now. You could create any function with a square root in it, or any function with a fraction, or any polynomial, and get the difference quotient of it. If you wanted to try an x cubed, you could. I wouldn't go further than x cubed. I wouldn't go to an x to the 4th polynomial. Okay? It's just too much work. Well, I got 1 minute to spare. I'm going to let you out early because it's a Friday. I know it's a nasty thing to say. Oh, I'll let you out 1 minute early. Shut up, Robert.